All right, simplifying radicals, day one. What I have listed here, and if you need to pause and write all these down, are a list of all of the perfect squares. And of course, you get those by doing 1 squared, 2 squared, 3 squared, etc. So those are going to help us because what we're going to be doing in simplifying sometimes is factoring. So we will need to be finding greatest perfect square factors. Square root of 9, of course, is just 3. Square root of 1 is 1. Square root of 36 is 6. When you have a number out in front, a coefficient of sorts, you just multiply. So the square root of 100 is 10. Think about your order of operations. You do exponents and roots come first. And then negative 1/2 of 10 would be negative 5. And again, with this one, 3 out front is just multiplying. And the square root of 64 is 8. And 3 times 8 is 24. So we'll be using some of those facts as we go along. We did this in our journal the other day. When you have inside of a square root or a radical, a times b, you can factor that into the square root of a times the square root of b. So you can factor what's in here that might be multiplied together into two separate radicals. And that's what we're going to be focusing on today. So, like I said, refer to the list of perfect squares at the top and ask yourself, what can 12 be divided by that is a perfect square? And that can be 4. And then 4 times 3 is what makes 12. So we're factoring 12 into this because then the square root of 4 is 2. And the square root of 3 we leave under the radical. Anytime that the number inside of the radical does not have any perfect square factors, then you are finished. Moving on to this one. 27 can be factored into 9 times 3. The square root of 9 times the square root of 3. The square root of 9 is 3. And the square root of 3 has no perfect square factors, so we are finished. The square root of 48 can be broken down into 16 and 3. The square root of 16 is 4, and then 4 times the square root of 3. Now, let me change colors for here and point something out. On this one, you might not have realized that 16 is a factor, so you might have gone to 4 times 12. Okay, which is correct. 4 times 12 is 48. The square root of 4 is 2. And then you have 2 times the square root of 12. And you might be tempted to start there, but refer back to this problem. When we did this problem, we did not say, oh, it's already simplified. So if underneath this radical there are any perfect square factors, you're not finished. You need to keep going. So then this would factor into that. The square root of 4 is 2. 2 times 2 is 4 times the square root of 3. So we got the same answer here as here. We just went about it a different way. Similar to when you might simplify 12 over 24 by going to 6 over 12 and then 3 over 6 and then finally 1/2, when you could have just right from the beginning divided both of these by 12 and gotten straight to 1/2. So factoring using the greatest perfect square factor will get you there quicker. This way works too. The larger the numbers are, this might be harder to find the greatest perfect square factor, so this way is going to work for you just fine. When there is a kind of a coefficient or a factor out front, we're just doing 2. We're going to factor the square root of 75 into 25 and 3. The square root of 25 is 5, so I'm going to show my work on this one. And then 2 times 5 is 10 times the square root of 3. We are finished because 3 does not have any perfect square factors. Okay, square root of 56. So this one you're thinking, oh, I don't know. We could do the square root of 28 and 2. So, but neither one of those are perfect square factors. So that isn't going to help us. Okay, you always want to be able to divide by something that is a perfect square factor. So even though neither one of these is a perfect square, it may be able to help me think, well, what could I divide by that's a perfect square? And I know that 4 is a perfect square factor of 28. Therefore, it is also a perfect square factor of 56. And that is going to be square root of 4 times 14. So the square root of 4 is 2, and the square root of 14. And this number seems large to me as far as stopping here. However, 14 is not divisible by any perfect square, so we are finished with that one. So again, demonstration on this one, it does not do you any good to factor this into something that is not a perfect square. So don't use 28 and 2. Definitely need to factor where at least one of them is a perfect square. Actually, if both of them are perfect squares, it means your original number was a perfect square. All right, 200. We can go different routes on this. I am going to factor out the largest perfect square, which is 100. And the square root of 100 is 10. So we have 10 times the square root of 2. And again, on this one, you can go different routes. Maybe I decided to go by the square root of 4 and the square root of 50. Well, the square root of 4 is 2, but the square root of 50 can be factored into 25 and 2. So this would be 2 times the square root of 25 is 5. And the square root of 2, so this route also takes me to 10 times the square root of 2. So again, larger perfect squares factored out make your work shorter. Other perfect squares will work as long as when you get to here, you don't stop. You keep going as long as what is under the radical has perfect square factors. All right, the 5 out front and the 72. I know 72 is divisible by 9, but I also know that it is divisible by 36. 36 times 2 is 72. So that makes this 5 times 6 times the square root of 2, which is 30. Oops, 30 times the square root of 2. Fix that. 30 times the square root of 2. Okay, you will be working these on without a calculator on a quiz or a test, and we're going to keep them all nice and smaller numbers like this. However, if you wanted to check yourself when you're working, you can do 30 times the square root of 2, find that decimal, do 5 times the square root of 72, that decimal, and those should be equal if we are correct. All right, on this one we've got 1/3, and then the square root of 18 can be factored into 9 and 2. So this is still 1/3. Square root of 9 is 3. And the square root of 2, 1/3 of 3, or 3 divided by 3. That's what 1/3 of something is dividing by 3, would be 1. We can write that 1 or not. And that answer is just the square root of 2. Good work.